In section 8.1, we're looking at finding angle measures in polygons. We're going to look at angles in two types. We're going to look at interior angles of polygons and exterior angles of polygons. The first, we're going to look at the polygon interior angles theorem. And this tells us that the sum of the measures of the interior angles of a convex polygon with n sides is n minus 2 times 180. Now, first off, when we talk about interior angles, we're talking about the angles on the inside of the polygon. And then convex is a term, we're going to have all of the shapes that we look at will technically be convex as opposed to concave. This just means if I extended the sides of the polygon, it will never have a side extend into another side. So this is, all of these would be convex. Concave would be something that looked like that. In that case, I could extend a side and it would be inside the actual polygon. It won't come up, just be aware of the difference between convex and concave, but for the most part, this whole chapter will look at convex polygons. So what we're saying here is I have angles, and in this case I have 6 angles in this polygon, makes it a hexagon, and if I added up all of these angles, no matter what type of hexagon it may be, I would get the total for those angles will be the value of n minus 2 times 180. Well, n being the number of sides, so in this case 6 minus 2 times 180 is equal to the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4, see if we can fit it in, plus the measure of angle 5 and the measure of angle 6. So what value is that? That is 4 times 180, or 720 degrees. So no matter what type of hexagon I may have, it'll be 720 degrees total, which is the rule we have here. The sum of the interior angles is n minus 2 times 180 when n is the number of sides. Now, the number of sides and the number of angles are technically the same value. We'll have the same amount of sides as we will angles. So this is our rule we use, but for the more popular shapes, we typically can just remember a triangle has a sum of 180. A triangle's 3 sides. 3 minus 2 is 1 times 180. A quadrilateral is 4 minus 2 times 180, or 2 times 180 is 360. A pentagon, 5 sides, will be 540. A hexagon will be 720. 7 sides is a heptagon.
All students who are not participating in an extracurricular activity at this time, please report to the front of the school to wait for your ride.
Heptagon will be 900 degrees. Octagon, that's 8 minus 2. It would be 6. 6 times 180 would be 1080. 9 sides is a nonagon. That looks like it will be 1260. And decagon, 10 sides, or 10 minus 2 times 180 will give us 1440. So this works on all the shapes, and if you really memorize the process to find that, and really they're 180 degree increments, you'll know what the total always is. But we always have this to fall back on, so if we're not sure. Or maybe the question is how many, or what is the total of the angles if it's a 22gon or a 30gon? If it has 30 sides or 30 angles, we can always go back on this. But typically, for the most part, we're going to be using these shapes as the total. So, in our first one, we look at our shape here. We have 5 angles, or 5 sides. So we're going to do 5 minus 2 times 180 to get our total. That is 3 times 180, or 540. So the total, no matter what type of pentagon we may have, the total, assuming it's convex, the total is 540 degrees. So 540 equals the sum of all these together, or 128 plus 113 plus 80 plus 138 plus the measure of angle 1. So we can combine those values, 128, 113, 80, and 138, and we get, let's try that again, 359. I think I missed a value here. Yep, I did. Let's try it one more time. It should be 459, I believe. Yeah, there we go. 459 plus the measure of angle 1 equals 540. We subtract that from 540 and we get 81 degrees for the measure of angle 1, which is right there. Now, keep in mind as you go through these angles should be between 0 and 180. If you ever get a value that's less than, or it's a negative value, or you get something bigger than 180, go back, fix, make sure you pick the right total, and we could kind of work our way around, maybe adding or subtracting 180, because that's really the increments they change in to find the value. But keep in mind, it always needs to be 0 and 180. If you get something that's a few hundred degrees, probably not the correct answer. So, if we go down, we look, we have 1, 2, 3, 4, 5, 6, 7 sides. 7 minus 2 times 180. That's 5 times 180, or 900 degrees. So for this one, I have 900 degrees is the total, and that's equal to the measure of angle 1 plus all the angles we have. Let's see if we can add it right the first time this time. We get 754 is the sum of these 6 angles. I now subtract that from 900, and I get that the measure of angle 1 is 146. So this one we have a regular polygon. And a regular polygon, or a pentagon in this case, because it has 5 sides, is where all the sides and all the angles are the same. Well, we first need to figure out the total. So I have 5 minus 2 times 180, or 3 times 180, gives me a total of 540 degrees. So that's equal to all the angles. Now I could call this one 1, this one 1, this one 1, and this one 1, but then I'm having angle 1 plus angle 1 plus angle 1 5 times. Really it's saying 5 times the measure of angle 1. So 5 times the measure of angle 1 means I can divide 540 by 5, and I get that the measure of angle 1 is 108. Now let's take a look real quick and see what if we went backwards on this problem. What if they told us we had a regular pentagon with interior angle of 108? How we would solve that backwards. So we know it has, well, let's change it again. We're playing with it anyways. Let's call it a regular polygon because we don't want to assume it's a pentagon yet. But how we may solve it backwards. It's a regular polygon with interior angles of 108. How we might solve a problem like that. Yeah, we know it's a pentagon and we know it's going to have 5 sides. But you may have problems you come across where they just give you, here's a regular polygon, find the number of sides. So I know that each angle here is 108 degrees. How many of them do I have? Well, if I'm solving, I have n of them right now. That is equal to the total for all the angles. The other way we have to find the total is n minus 2 times 180. So I need to solve for this. This is, all the angles are 108 degrees. I have n of them. That's what I'm finding. I don't know how many I have. That's what I need to find. And then this gives me my total, which is the rule we already have. So I can solve and say 108n equals, and this is just distributive property, 180n minus 360. I can now subtract 180n from 108n, and that gives me negative 72n equals 360. I'm then going to divide negative 72, oops, this would be a negative 360, by negative 360. And that gives me n equals 5, which what it should be because we started with a pentagon. But this may be a process you may have to use to go back and find the number of sides you have. Okay, next we go to our exterior angles. So now the sum of the measures of the exterior angles of a convex polygon, so still convex, and that's with one angle at each vertex, is 360 degrees. So now I have angle 1, 2, 3, 4, 5. And this time, when I add them all together and go up to angle 5, I'm told it's 360 degrees. So we sum it up. The sum of the exterior angles is 360 degrees. Now we notice, is there anything there that says something about the side length, or the number of sides, or the number of angles? There's nothing. It just says 360. And that's the case for exterior angles. They will always have a total of 360. Whereas interior depends on the number of sides, or the number of angles. Exterior will always be 360. So, if I have any number of sides, I'm always going to add them up and set it equal to 360. Let's take a look at a couple of those. First one, it does have 4 angles, but it's still 360 equal to the measure of angle 1 plus 76 plus 88 plus 117. That gives me 360 equals the measure of angle 1 plus 281, and I subtract that from 360 and get the measure of angle 1 is 79. I go down. What's the total again? It's still 360 equals the measure of angle 1 plus, I'm going to add these together, 55 plus 86 plus 52 plus 82 gives me 275. I subtract that over and I get 85 degrees. And the last one, this is now a regular hexagon. The total is still 360, but I have 6 angle 1s. Divide 360 by 6 to get the measure of angle 1, and it turns out to be 60 degrees. Now, while we're looking at this, let's look at a couple different questions. First of all, if we know the exterior angles are all 60 degrees, what would the interior be? Well, each interior and exterior angles are a linear pair, or they're supplementary. So if it's 60 on the outside, it would be 120 on the inside. It's a supplement. And I could do the same thing on any of these other problems. If I had an exterior angle, the interior is its supplement. Well, if this is 120, I had 6 angles. 6 times 120 would give me 720, which we found earlier was in fact to be the total for the interior angles of a hexagon. Now, let's pose another question again. Let's say we have a regular polygon with exterior angles of 60 degrees. So how would we find the number of sides? Yes, it's the opposite of the problem we just did, but we could still check to see how we would find it and make sure it does come out to be the same answer. So now we know that I have 60 degree angles. I need to find how many I have. So I'm going to do 60 times n. So let's say, for example, I had 10 of them. If I did 60 times 10 and I had 10 of those angles, it would be 600 degrees. Not the case here, but that's the idea we're going with. So now I can take 60n and set it equal to the total for the exterior. Well, the exterior doesn't depend on the number of sides or the number of angles. It's always 360. So I could do 60n equals 360. If I divide both sides by 60, I get n equals 6. It turns out to be a hexagon like the problem we looked at here. So we can use that to jump between them and use that to your advantage. If you ever have interior angles and you have a problem like this, try to find the exterior, because the exterior always has that parameter. It has to be 360, whereas interior, n minus 2 times 180, can add a little bit more work to it. So exterior are always a good option to go for.